Hey physics. Okay, so I'm going to go over this slideshow right here, like talk you through it. And what you need to do is click on this blue one, and this is your student notes for this. Okay, so as I'm talking through this, you should be taking some notes in here. You'll see that like as I'm talking, this syncs up with what I'm talking about like pretty closely. So let's get started. All right, so on Monday or Wednesday, you learned that a force is a push or pull of an object resulting in, so basically like a force is something that is causing an object to move, or it's like acting on an object. It's a push or a pull that if it's unbalanced, it's going to cause that thing to move. Yeah, so that interaction is the force that's happening there. So now we want to know about ways to categorize forces. We're going to look at like six different types of forces that can happen here, and how we measure them. Yeah, what are the different types of forces here? So you are going to take some notes in that student slideshow that looks like this, okay? So how can we categorize forces? There's two different kinds of forces here. There's contact forces where they're actually, you're like connected to the other thing, like you're touching the thing, or this is an example of where like maybe the person isn't touching the dog, but the force is having an impact on the dog. Everything is kind of like touching, interacting. Whereas action at a distance is like magnetism, it's like electromagnetic forces, things that interact without touching. So some examples of contact forces include frictional force, like when you rub against something, the force of friction it's a thing. There's tension force, like the dog on a leash. There's that tension between the leash and both the dog and the person's hand. There's the normal force, which is the support, like if something is resting on a table, or like I'm sitting on the couch right now, so the force of the couch holding me up is the normal force. And then air resistance is like if you are driving down the road and you've got your hand out the window, that air resistance is that force that's hitting your hand as your hand is like blowing in the wind. Applied force is when you actually like move something. That's kind of like what we would normally think of as like an actual push or an actual pull. And then spring force is what you have when you have a spring, right? And that spring is pushing both, like pushing back up if you're pushing it down, and it's also pushing down on the surface that it's resting on. Or like if you were to hold a spring in your hands here, then it would be pushing on both of your fingers, right? So then the action at a distance forces are gravitational force, so kind of the opposite of normal force. As I'm sitting here on this couch, the couch is holding me up, and that's the normal force. And then gravity is pushing me down, so I'm not floating up off the couch. Electrical force, which is what we learned about with atoms earlier this year, and magnetic force, which you guys already know about. Those are action at a distance forces. So let's look at these forces one by one. So gravity is what happens when a massively large object, like the Earth or like the sun, attracts another object toward itself. So we're always being pulled down towards the center of the Earth. In the same way that the sun is kind of always pulling us towards it, but we have this orbit that's kind of keeping us in place. But the sun is what's holding us in its orbit with its gravity, and gravity is what's holding us onto the Earth. So normal force is the opposite of that, where like if this water bottle is resting on this table, then the table is pushing up on that water bottle in order to keep it right where it is. Let's see. Okay, so then there's friction. So if I'm pulling a water bottle across the floor, then friction is just the rubbing. It's the frictional force is like, because that's going to take some energy away from the system, right? If I'm like pushing or pulling through the air, it's going to have less of an impact than if I'm pushing or pulling across a surface. And actually, I'm going to switch this around because the frictional force acts, it goes in the opposite direction as the applied force. So the applied force is the act of pushing or pulling. So it's this hand that's pushing, applying a force to the water bottle, pushing it across the table or the floor. And then air resistance is not going to have much of an effect on this water bottle, but if you are an airplane or if you are a piece of paper falling down, then that air resistance is going to have a big impact on how you move and how quickly and things like that. So in this situation, a water bottle is being pulled across the floor at a constant velocity by a rope. So we have a tension force, and tension forces are cool because they both push and pull, right? Like if I have a rope hooked up to this water bottle, then that rope, when it is tense, it's pulling on me and it's also pulling on that water bottle. So that's why that tension force goes both ways like that. And a spring force also pushes and pulls both ways. So, and I'm gonna fix that real quick too. Basically, yeah, it's pushing up on that water bottle as I'm pushing it down, as I'm applying a force downward on that water bottle. The spring is pushing upward, and it's also pushing downward onto the table. Let's see. So how can we describe forces? So we use a unit called the Newton, named after Newton, the guy who had an apple fall on his head. And 1 Newton is equal to 1 kilogram per meter per, like a unit of time, basically, a meter per second squared. So that's a unit of acceleration. Don't worry about it too much, but it's basically like how much force it would take to pull a 1 kilogram object, like make it go 1 meter per second faster each second is what that means. And you would just read it like this: 10 newtons, like this, 10 newtons of force, 10.0 newtons N. Okay? And another important thing to know here is that force is a vector quantity, and what that means is that it has a size and a direction. So, yeah, as opposed to something that just kind of is like floating around, we know how big it is and we know what direction it's going in. We can see how much of a force there is in a direction. Okay? Gravity pulls down on a bowling ball with 9.8 newtons of force. Okay? There you go.